I am currently recording, so anything you say can and will be used against you in the court of judgment of your peers. Okay. So, what is a rate of change? Can you guys think of any examples that you would have heard of that would be rates of change?
Age.
Age? And how do you mean age?
Like every year you become one.
Yeah, for every year you gain a year of age, right? On your age. Tenno, do you have a question?
Nothing.
No? What about you get in your car? What do you do when you get in your car?
Increase speed.
Okay, you drive, and when you drive and when your speed increases, miles per hour is a rate of change. So a rate of change is a value. I'm going to have to write small in here. Use the lines differently than I. A value that describes how an output changes How do you spell what? D-S-C-R-I-B-E-S. How an output changes relative to the input. Okay. A value that describes how an output changes relative to the input. So what is output generally? What value do we usually use for output? Y is generally the output, and the input, it's generally the X, right? If we're in science, sometimes the input is time, and the output could be distance or maybe speed or velocity. All right, so how do we find the average rate of change? You guys ready for that? So first we have to be given the value of a function given the value of a function at different points x1 and x2. So remember, the value of a function at x1 is the y value when x is 1. Does that make sense? And the value of the function at x2 will be the y value at x2. So that's what it means, given the value of a function at different points, x1 and x2. So the first thing we do, step 1, is calculate the difference. What does the word difference mean in math? Subtract, right? Yeah. The difference, y2 minus y1, okay? And another way we could write that is f at x2 minus f at x1. All right, those are identical ways of writing it, okay? y2 minus y1 is exactly the same as f at x2 minus the function f at x is 1 at x1. That's also, we use the symbol delta y. So this symbol delta means what? Have you guys seen it before?
Yes, triangles. Yeah.
It means changing.
Oh,
Change. Changing. So it's the change in y, okay? And this is change in x. And how do we tell how things change, right? You subtract. right? What is your tone? Please do not cut the socks. So we have a change in y, okay? So that's what we're going to do. We're going to calculate the difference. What is the change in the y values? So what do you think step 2 will be? Calculate what?
Calculate x. Difference with the x.
Yeah, the difference. X2 minus x1. Okay? That's a 2, not a z. X2 minus x1, which is the same thing as the change in x. And the third step will then just be find the ratio. Delta y over delta x. Okay. Does this remind you, this formula, does it remind you of anything we've seen before?
The midpoint formula.
Okay. It looks a little bit like the sort of like the distance. It's part of what we found for the distance formula. In particular, Tong. It's called a baby sock. Put it down. This is a change in y over change in x. Where have we seen change in y over change of x in x? Where have we seen that before?
It's one of the equation.
It's the slope. Yeah.
What is
So the slope of a line, rise over run. It's the change in y over change in x.
Have you seen that before?
What?
Yes, I've taught you that before. Okay.
Oh, have I heard?
So again, note that f at x2 is the output. When x equals x sub 2, right? So it'll be given to you. So that's the output. When I give you x is a number, let's say 4, right? When I tell you what x equals, you have to find the output or the y value, okay? And this here is the function, the output when x is x sub 1, or that first number. Okay, so this is a lot like slope, right? Slope of a line. And that's in particular, that is what the rate of change does. Okay? Change in. It says change in. All right.